Hi, everybody. Welcome to our third presentation on PHP. This one is titled Web Focused Programming. This class, we're going to be kind of covering some basics of how to start writing web-based applications using PHP, why you want to use PHP for this, and some of the general features on kind of getting going. This is all building off of the previous two presentations. So if you're catching this on the replay webcast and you've not watched those yet, I highly recommend you go do so. Just a real brief about me. I've been working with PHP for quite a long time. I'm Tom Beebe. I work with Advanced DataTools. I have been for over the last 10 years. Heavily involved with the Informix community, and I very much enjoy giving these presentations. So webcast series, 4 webcasts. This is number 3. The first 2 are already up on our website, so if you have not watched those yet, I recommend hopping over to it, or if you need a refresher. Our next one is going to be June 17th. This is going to be building off of what we do today, and then going into some other cool features with PHP and some advanced topics around it. Okay, so what we're actually going to talk about here is how does actually doing a web application work? We're going to talk about doing basic sample code, getting into forms, some of the different PHP functions, get, post, request, file, what those do. Actually going to build some forms, connect it into Informix, deal with session, and then talk about some other things that you may want to research if this kind of hits your interest trigger or is relevant for your job. So this bit about how does a web call actually work stems from when I gave this class a couple of years ago internally. One of the things that I realized is most of the people that I was working with and was actually giving the class to had primarily been doing traditional programming, command line based, some graphical based, but it was always a standard. You have a program on your system, you run it, it has input, it has output. PHP, when you're dealing with web-based, is a bit different, and this is the case for any web-based language. Whatever you may be using, it's all going to work this way. But to do a basic web call, I am on my browser. I am the client. I am going to make the call from the server, which is the web server, which might be my server, it might be google.com, it might be cnn.com, it might be wherever you're going on the web. And how does it actually work? Behind the scenes, what happens is you go to google.com, you make a request, get the main page, which is usually index.html. There's a few other possibilities there. Index.php is another common one, whatever the default is, and your browser will request it from the server. The server then looks in the web directory, whatever is the default web directory, looks for that file, and will initially return a status code. The first one is if it's a 200, it's a success. The file's there, we can access it, etc. If it's a 300, it means there's a redirect call. So it's going to actually tell it, oh, we actually need this file. There'll be a new request made, and it will then send the updated file. This is used if you've moved one page to another location and you want to, the server owners have said, you need to go look for it here. There's the 400s. Most people are familiar with 404, error not found. There's a whole series of error codes. If there's something wrong, you'll get a 400, and a 500 means there's a server error. This is pretty common if you have like a seg fault level or a major error in your script. Assuming, we're going for index.html, it exists, we have permissions to it, everything else, it'll be a 200. What'll happen is your web server, whether it's Apache or iPlanet or whatever your actual web server is, will read that file from disk, just in its exact content, or if it is cached in memory, it'll just pull it out of memory and send it along with a little bit of header information. The browser then receives that HTML code. It comes in a stream, so it's not, which is why you see your page display sometimes a little bit at a time when the connection's slow. And the page will actually render live as you're getting the data back. As it's loading, If it has any redirects or any code in there to actually pull other things like CSS files, cascading style sheets for how the actual page should be displayed, or JavaScript include files, or there's a series of other ones that may be included as well, image files, it'll actually real-time, as it sees that call, your browser will make another call in the background out to wherever that file is located and do the same process, requesting each one in turn and then loading them in. It's why often if a website is slow, you may see the page load, and then a second or a fraction of a second later, you'll see all the styling all kick in at once because it took a little bit to get that style sheet, or the JavaScript may take a moment to kick off because it may have taken a little bit to fetch that JS file. So it all works one script at a time. But the thing to keep in mind when we're dealing with PHP and dealing with writing a script is it's a static. As soon as the file is starting to be fed back, and as soon as your browser receives it, that's it. Unless you're fetching new files, you are not actually getting any more dynamic code. Everything has to be dynamic at the time the script is run, not when the browser is seeing it. So it takes a little bit to get used to this if you're coming from a traditional, especially from the C world level, the C world or 4GL or any of the, direct, it's all on the server type of scripts, because now we don't have the dynamic control when working just with PHP. So if we want a web script, if we're doing a PHP file, this is also true for if we're doing a Python web script or a Perl script with CGI or JSP or any number of other web-based languages. How does it actually work? The browser is going to send a request for index.php or request.php, or whatever the file may be that we're looking for. It does a GET call. The server returns the status code. Let's say it's 200, the file's there, we can access it. What happens next is the web server, and I'm going to assume it's Apache here, goes in and sees that it's a PHP script. So what it starts doing is it starts reading from the top down, and if it actually encounters the start PHP line that's less than $PHP, it'll start processing. And what it does is it has the Apache module loaded into the PHP module loaded into Apache memory. It'll hand that off to the PHP module to process. The PHP module will run the script top-down, handling any PHP code in there. And what it will return when it's done is generated HTML code. Your for loop that you have in your script will go ahead, process, print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that'll all be static text, which is then handed back to Apache, and which then sends it back just like they would with a static HTML file. So what you have, your dynamic code generates a final script in HTML and then sends that all back in one fell swoop back to your browser. Or, it streams it back, but it effectively is one static page on time of load. You're not going to have it keep updating unless you have outside dynamic code to handle it. But PHP itself is only on the server. And that is one of the key things to remember. Once it is shipped back to the browser, you can't change it directly through PHP. That's where some of the other web technology comes into play. If you have just pure HTML code that's not inside of PHP tags, it will just be treated static and just be sent back exactly as is. And the browser will just display the HTML that it gets back. If you take a web-based PHP page and just output it straight on the command line, you'll get the exact same thing that your browser will get sent back to you. So some basic web code. Most people have seen, I'm hoping, have done some HTML at some point in their lives. Everything starts out, it's wrapped in these tags, starting out with HTML, telling it, this is the beginning of an HTML page. I will add, especially those that haven't written web code in a long time, there's actually some headers you generally want before the HTML. I don't want to go into all of that because there are some variants. A quick Google search will turn up generally what you need. That just make it the web browser know exactly what kind of script it is, if HTML versus XML versus something else. It's something that you didn't used to need to use. It'll display fine without it, but it just helps avoid getting any warnings. But at any rate, this is perfectly valid code. Start with HTML. You have your head, which may have your title, may have meta information, you know, any number of things. And then you have the body, which is actually what's displayed out to the screen. And then what we just have here is a very simple, you know, the value of X is, you know, and then it actually does output in the little tags for, you know, less than $PHP and then just echo X. So everything there is treated as pure HTML until it gets to that open and close PHP tags. Everything in that is treated as PHP script. And you can embed it that way. It'll output that way, and you get your code generated. So you basically will say the value of X is, and then whatever X is. It might be 5, it might be 20, maybe unset. But you'll actually have that all printed out as static HTML and then shipped back out to the browser and then displayed. I will be showing a bunch of demos here in a few moments. Another way to do it, and this is easier for if you're doing templating, is to just wrap everything in PHP and treat it all as one long string or a series of strings, and just echo that, echo or print, however you want to output it, that string once you fully completed it. This method's a little bit better if you have dynamic content, because that way you can inject information into the larger text bit, into the larger HTML, without having to stop the stream or do anything else, because you're not going to actually send the stream out until the end. The time you wouldn't want to do this is if you have a really long page or something that's going to take a really long time to generate. You may want to output, you may want to print or echo things out to the browser initially to let people know that it's processing, get the process kicked off the browser, start displaying something, run your long process, and then output the, you know, results afterwards. For some of the larger reports, that can be a way to do it. Most of the time, though, you generally want your web pages to load in under a second. Normally, you want them in sub-second range. Because people are, you know, unless they know they're running a long report, people are very, very finicky on time. You know, they want things to load now or yesterday in most cases. So you want to make sure your scripts are optimized, and this is a way to be able to get more control by setting everything as a single string on this line. You know, basically you set the variable line to be this long string which has all the PHP in it, and then we just echo that out. It means you have a little more control. You know, it depends on your environment. Both ways are perfectly valid. So I'm harping on this again because I have talked to enough people that there is some confusion about this. The browser versus server. Your browser is the application you're running. It's also the client in a client-server model. The server side is the Apache server, web server, whatever it might be. That is where PHP is actually running. The PHP is processed at the time of execution. So when the page is requested is when the PHP will actually be executed. Everything will be run at that time. Once it's sent, the PHP script is finished. It's not continuing to run unless you have some kind of for loop, but it'll still consider that the web page is requesting. So you want to have your PHP code be entirely self-contained within that particular web page or particular request. If you need something that is more of a dynamic model, you can have a PHP, you know, application server effectively running where you have a script that just runs in the background and you do calls separately to that. Most applications, especially web-based ones, it's everything is contained within your single script. When it is called is when it is all compiled and all executed, so please keep that in mind. Once the script is completed, it is sent back to the browser displays it. That transaction, that application session is done. Just like if you were to kick off any Unix command on your server, you run a grep, you run a tail. As soon as that last line is outputted, the program finishes. That's done. That is the state of the session of your application is now complete once that page is sent. There are ways to keep pieces between page loads, but each page load is its own execution of the code. If you need more dynamic applications, is where JavaScript, jQuery, and then the stuff on top of that, such as Ajax, comes into play. where you can then make the browser do extra requests or extra things or do all kinds of changes to the page after it is finished loading. But that is outside of PHP. PHP, each web call is its own execution. So just making sure everybody is clear on that. So I'm going to go into a couple of demos here. The first one is just a simple piece that I want to show, which is, I mentioned this at the beginning of this, first session, but it's PHP info. This is PHP info, single command. When it is called, this will give you all the application, all the information of your PHP system. It's individually run, so what happened here when we did this request is I made a request to my web server at this IP address. I requested specifically this path and this file. So Apache then saw my request, checked to make sure that file existed, saw it was a PHP script, and the PHP script started, so then passed it along to the PHP module that it had in memory. The PHP module executed it, and it executed the same as if you run PHP on command line like we did in the last two sessions. Takes that output, the entirety of that output, just like you would to a command line, and then takes it, hands it back to Apache, and Apache streams it back to my browser. My browser then displays it, and it's up here. So I have all this code up in here, displays, shows me all the information about my script, or about, not my script, about PHP, Apache, how the settings are. And at the same time, if I run this on the command line, and this is going to be a whole bunch of information, but I'll output it so it's a little better displayed. So what I did is PHP just did the command line run of the same script, the same exact script, and it gives me a nice text output. And if I was doing it through HTML, it would give me an HTML output. And every time we do it, every request you make will work the same in terms of the output between HTML and command line, which again makes this really nice for system administrators who may want scripts that work between the two. The next thing I show you, I'm hoping I'm not going to mess this up because I don't use this nearly enough. It's actually telnetting to my web server. Apologize, I had this up a moment ago. Again, I thankfully don't have to do this very often. And what I'm doing is I'm requesting a script, requesting slash, which by default is index.html, giving it my host. This is the same thing your browser says. So what I'm doing is I'm passing it the GET request, my host that I'm coming from. I think that's actually all I need to put in. Oh, and it returns an error because I typed up should have had the host name there. But I'm going to show you what I did before. Telnet to localhost, requested the GET on HTTP 1.1 version, my host localhost, and then what it does is it returns back this information where you'll notice the server information, the last modified, the last time the script was modified, the content type. It'll actually return back the status code here with HTTP 1.1, the status code of 200, and OK that it's good, and the content type, text HTML. And then it returns the straight HTML. This is what your browser sees. All of this, you can go in, dig through the information, view source, and this is what is returned. I keep harping on this because I want to make sure everyone is on page here with how this whole system works, because it is a complex client-server-based model that a lot of us just take for granted because we've been using web pages for so long. We don't think about the technology and the protocols and everything that go under the hood. And when you start working with forms, and especially with more advanced PHP, you do need to keep that in mind. You do need to keep order in mind for how things work. So I'm going to get into forms now. Forms, we have all used web-based forms, whether it is signing up for that bank account or posting, some obscure joke onto a Facebook, whatever. We all use forms online all the time. They're embedded, they're standard HTML. There is nothing, hard or, complicated with them. They try to make them very, very straightforward. The most common types, and there are a few others, but I'm just going to focus on these primarily. Text, this is your standard text box. This is your first name, last name, etc. Text area, this is your comment box. This is the big box that you can put in multiple lines. If you hit return, it gives you a new line, not a submission. Radio button, these are little round ones you've seen. You only select one of a group. Check boxes, the ones where they're square and you can select multiple. Select button, or it's not actually a select button, it's a drop-down list. The submit button is a button you press, submit a form. A button type is purely a button that doesn't submit the form, but you can have it do something else. Hidden type. Some people don't know that there is a hidden type of form elements. These are elements that aren't displayed on screen, but you can modify. These come in very, very handy when you're doing dynamic coding using web forms. The other one is file. You have to have a special form type for this. We'll talk about a little bit. We'll talk about this more in the next session. But there's actually the ability to submit a file as binary code up through a form. So every form starts with a beginning form tag, ends with a end form tag. Everything within those two tags is considered a single form. Each item needs to have a unique name. The only exception to this is the checkbox type, which because you have 5 or 6 checkboxes, they're all considered the same name. Actually, radio buttons are the same thing. For each form, for the form tag itself, you have 2 general parameters you're going to use. The first one is method, post and get. I'll talk about that in a moment. The second one is action. This is where you are actually submitting the form to. You can set it up. A lot of scripts you'll want to do this, where you actually submit it. You set the action to the form name itself, so it submits back to it. So just at the top of the form, you check to see if it's there's data coming back. Other times you'll want to have it submit to a submission page, where you have your input page and then a separate page to actually trap the data coming in and handle it. Either way is perfectly valid, depends on the application. When a submit is called to the form, whether that is through a submit button or through JavaScript calling submit against it, the form will take all the data in that form, attach it to the send it to the action target. So if you send it to submit page.php, it'll take all those form fields, all the values you have, and then send that to that page. And then you set up that page to handle them however you want. There is one little feature and this is a PHP specific, where I mentioned that each form has to be uniquely named. The radio buttons and the checkboxes do not. However, with checkboxes, if you actually set the name with open and close brackets at the end of the name, it'll actually pass all of the values selected as an array. By default, it does it just as comma-separated list, which can be a little hard to parse. Having it just send an array tends to be a little bit easier. I'm not going to get into that. I just mentioned it here just in case anyone on the call or anyone that's listening to this later on starts using this heavily. That can come in really handy. It's just a little trick with PHP that can be very useful. So what actually happens? So the browser requests a web page with a form, sends it back to, I receive it from Apache, talk through how the whole process works. Maybe it's I'm filling out an application for a car loan, for example. I fill it out, I, check everything's good, I hit submit. What happens is my browser looks at that form, looks at the action, and when I hit submit, it is going to request that page that I'm targeting in the action. It'll then, as part of that request, append all of the form fields and key value pairs. So you have your field name equal to, and then whatever value you are passing it. So first name is Tom, last name Beebe, etc. And then passes that all in the same request to the action and the action target. Then the server will take it, run the code, so it'll run your target script. It's maybe submission.php. And then takes it, handles those fields, just like you pass arguments through a shell script, argument 1, argument 2, argument 3. In this case, we're passing our argument as part of the script, as part of the request, and then so we can actually then parse those fields in very similar ways. Then the code does whatever you want with submitted data and then sends the results back to the browser as a new page. So just think of it as loading a new page, passing in some variables. So get versus post. When I mentioned this earlier, is there are two types of ways you can pass data. One is get, one is post. Get passed it through the URL web. The best example I can give to you here is just about any search engine. So we go to, actually not going to choose Google here. We do Yahoo, and when I send a request to Yahoo for search, it goes search.yahoo.com, and then what it does is you give it a question mark, and then P equals test. This is your parameters. This is the key value pair. The key is P, the value is test. That is what I'm searching. So what it's calling is the search page, whatever language that might be in. And then it is passing these variables here, P equals test, EI equals UTF-8, and FR is MOZ35, probably from Mozilla, to that script. And then that script is running with those three arguments and then returning back whatever the appropriate values would be. So get is very nice for doing things like search results, because what it does is everything is in the URL bar. It makes it very easy to go back and forth to pages. You can bookmark a page with a get line. So if you have a particular search you may want to have somebody directly link to, you can very easily do that through a get. Also, it will easily index on search engines, or if you have a caching system, will very easily cache all of that. The downsides, though, is you're limited to about 2,000 characters, which seems like a lot, but if you start having large text fields, it can fill up really quickly, and it depends on the browser. 2,000 seems to be at the minimum. Some browsers do a little bit more, but if you have a larger form fields, you're probably going to hit that limit, and that can be a real problem because it won't give you an error. It'll just truncate at that point. You can't pass binary data. Because it's going through in the URL bar. Binary data may not come out the other side the same way. Can't do files. So it has some plus and minuses. It is the default, by the way. If you don't specify a method, it will go to get. The other way is post. Post passes the data rather than as part of the request as a separate, or as part of the request. It's not directly as the URL request, but it is part of the request and a binary block of data that is sent to the server. You can pass files through it. You don't need to URL encode. You don't need to worry about any, control characters going through. Back will not work. If you've ever been to a website and hit back and said, are you sure you want to repost this data, retry or cancel, that's what's going on, because you have submitted data to a form in such a way that it may not be a static state, and it doesn't necessarily want you to submit again. You just submitted a payment to your credit card. You don't want to accidentally hit back and have it submit another one for you. So it has some plus and minuses. There's really the only limitation on length is in your PHP INI telling it how, or your Apache system telling it what is the maximum. Most systems default to like 2 or 4 meg. Plenty of them I've seen bump it up to 8, 20 meg. Sometimes for larger files, 40, 50 meg. Every system's a little different. It depends on your environment, how long it can actually be, but plenty long to handle any kind of data you really want to throw at it if you configure your system correctly. So if you have a complex form, that's the way to do it. If you have a login form, make sure it's post, by the way. Because GET actually passes the arguments in the URL line, it means any logs on the server will actually pass those arguments into the log. So you'll actually have things, if you're to pass a login system via GET, it means both that person's browser history as well as your URL log and your Apache system log and anything else that's actually trapping web pages requested will include that username and password. So make sure you use post for those. So PHP on the other side, how do you actually deal with this? Actually, I'm going to hop and show one more example here first. And all these scripts, by the way, will be included with the samples file put out in a couple of days on the website. And one of them I've called forms.php. If you can't remember how get and post work, this is the way I recommend it. By default, this form is in method get. And what it's going to do is it's going to submit to itself, and what I have here is 3 form fields. I have form field of text here. One I didn't mention, it's called password. It works the same as text, but it actually hides the characters you type in. And then a text area here. And what I'm going to do is, is submit the form, and it pulls back the data here, and it shows me what I've passed. But what you actually notice up here at the top is forms.php, and now I'm actually passing information. Form type get, what the hidden field, which I include a hidden field in here. Again, you didn't notice it, and that's the value for it. And then your name, Tom. Password, again, why you don't use login password in with the get type, and then the text field. So all of this is passed in the URL. Again, the advantage is I can do something like cut and paste that value, link it to somebody, and they get the exact same values I get. Because it's considered that that is the full request, it doesn't have to know anything else. That's all it needs to know to process. So there are some very good places for this. But if I hit this button here, it's going to switch it to post. And what I'm going to do is it's refilled in the field. I submit the form. Now it's, I'll change this so you see it's a little different. You see it submitted this time with your name changing. It takes all the data I want. But now it's passing it through post. You notice the URL bar is not showing anything. It's just showing the target. And that's all it's doing because it's actually passing that data through a separate part of the request that's not in the URL. And if I go hit it back, it's actually going to give me this. Displays page, Firefox must send information, or repeat any action. This is a reminder with your browser that this is a post field and you're having to resend it. So I can either resend or cancel. So keep in mind when your users are accessing your site, you may not want them to actively go back, in which case post is a good way to force it. On the same time, if you want them to easily use the back and forth buttons, you probably want to use get. It all depends on your application. So a little bit about handling data here. There are several predefined, we talked last time about some PHP included global variables. These are the ones we actually care about for handling user input through a web. The first one is post. It handles post data. What it is an associative array of any field sent in through post. So you'll have your key value pairs where your key is the post variable associated key, and then the value will be the post value. Get, same thing with get data. Request is nice because it gets both. On a number of scripts, you may have cases where you may have both post or get data coming in. You might have a browsing, a case where you have a search field that back and forth, but it can also submit a custom thing which you may want through post, or might be too long to handle through get. There's any number of reasons why you might have both coming through the same page. Request is a way to do that. It's also just a way to lazily do it. Some people don't like to use requests because they say it's security reasons. The reality is anything coming from a client, from a user, from their browser, you can't trust to be in the way you want it to be. The only way you can be safe is to sanitize your own data. And it doesn't really matter. I have a browser out on, I can change any form I want to on the web from post to get, and their server would never be able to tell the difference. So request is not going to save you a whole lot in terms of security, or would not really cause you any real security concerns as long as you check your data on input, which you want to do anyway. File is a custom one. We're going to be talking more in the next session about how actually to handle files being uploaded. And all of them, again, are associative rates. So down here, giving you an idea of what it looks like, you have request, and then the user ID would be the key. That is the form, the name of the form field from the submitted form. So user ID is Tom. That's on the form. I hit submit. And then on the associated script that's taking that data, I can use request user ID, and it will return Tom. This is how you pass form from one script to the next, or form data. Make sure you use the right handler, get versus post. It depends on your situation, which can be appropriate. Don't trust anything from your form. Sanitize everything. I don't care how many scripts you put in, JavaScript otherwise, to tell you only put in 10 characters, or it must be a number, or it must be a valid date. Users either intentionally or unintentionally will find ways around it. Don't trust them. Always sanitize, always check, and when possible, give handy error messages. I've seen plenty of times where there's, a simple script, especially on older sites, to check to make sure a date coming in is valid, and they didn't account for, the skip leap year. And so, users trying to put in February 29th when there isn't one, the JavaScript didn't hit it, the JavaScript checking for that didn't do anything. They just pass it straight through on the script, and suddenly they're getting back, some big Informix error or some big database error, whatever it might be. Always check every bit of input. Make sure your dates are valid. Make sure if it's a number, it's a valid number. Make sure, if it's going to be divided, you're going to use the divisor, that it's not 0. All these little things, please check them on input. It only takes an extra line or two of code to do so. You'll save yourself a lot of headache in the back end. The special predefined variables, the associative rates, post, get, request, are available anywhere in your script. They are considered global. You don't have to specify them in the global set. They'll do it automatically. So you can just source them in anywhere in your script you need to. It really is that simple. There is no extra features you need to add into PHP for this. There is no jumping through hoops. That really is all there is to it. So a couple of samples here, and I'm going to get into some more script-based samples, but I just include a few, so if you're just looking through these slides later on. This is what a simple form looks like. You have your form, you have your action, where it's going to be posted to, your method, post, your input type, text, size 20, which the size, by the way, with input, if you've not worked with it before, that is the length of the field, how big it actually displays on screen. There's a second parameter called max length if you want to actually limit it to so many characters for text. And then the name, a first name. Then your select, which would be, in this case, calling it state. Select is a little bit of a different syntax where each of the values is a key value pair. And you see the syntax there of option value and then end option, and then end select. Input type, then we have a submit button, and then the end of the form. Again, a lot of you may have worked with forms somewhere in the past. Most people I talk to have, but just a little refresher. So I'm going to get into some samples here. pull up this one first. I'm going back in, building off of what we built last time with connecting it to PHP, or connecting to Informix. So we built it up with Informix. We've got Informix there. There's a little script I will be including with the samples called create user input. This is a very, very simple, just creates a very simple static table to track users. So all you do is just create that table. Just if you're running these samples, make sure to run create user input first. I have already done this, so I'm not going to run it again. I'll just give you an error. And what I'm actually going to show you here is a very simple add user script. I have a class called user class. We talked about these last time. What this does is it goes through and manages loading, saving, etc. From that table. I'll include it in here. I'm not going to go through it all right now. We talked about these last time. But what I did is I created a script around it called adduser.php. And we just include the database connection, user class. First name is the first argument, last name is the second argument. Creates a new user object, sets the first name, first argument, last name, second argument. It's going to print out what that object looks like. It's going to save it and then print it out again. And the first thing it's going to give me an error because I forgot to put in a name. So I need to give it a first and last name. These are samples. I haven't done full error checking or anything else, of course. So what it's done is I've given it first name of test, last name is user. The first object you see, the first name here is test. The last name is user. There's a serial ID is set to -1, so it's not set yet. There's no error. Tell it to save, and then after it's saved, the serial ID is now 4. The first name is now test, last name is still user, so it's saved in the database as test user. What I then did is created from the same script a simple HTML form. So HTML start, title, form, and the action is add user web submit.php, and we're giving it and we're telling it to send through post. Same input fields, the first name, the last name, and then we just have a submit button. So it's only 3 input fields, first name, last name, and submit. We have it in a simple table here. If you haven't worked with tables and you're looking at doing this, I would recommend redoing some basic HTML research. It's all kinds of stuff all over the web over it. But all I have is in a simple table. So to show you what this looks like, and nothing up my sleeve, this is what it comes out at. First name, last name, and your save button. So let's say first name is web, last name is test. And what it will do here is it will go to form action, add user web submit.php. So once I hit submit, it is going to request this add user web submit.php script and pass along these form fields as arguments to that script. So I hit save, and what it's going to do, and the add user web submit does the same thing. The before user class, it displays it just because it's straight text. First name web, last name text, serial ID is -1, and then after the save, serial ID 5, first name web, last name test. And to show you the web piece, so it is almost the same script here. First name is coming in from request first name, last name is coming from request last name. So rather than arg1, arg2, I'm using request first name, request last name. User, first name, last name is set to the appropriate variables, prints it out, saves it, and displays it. So we're having the exact same class, exact same database connection file working from the command line as well as from our website. You see, it doesn't take a lot of code here. We're only using 2 lines of web code to do that. Everything else is straight printout. Notice I do not use I'm not using HTML code in the script other than just the BR, which is new line. Browsers will perfectly fine to handle straight text output. Just be aware it doesn't always format entirely cleanly. It's not going to look as nice as if you're doing straight full HTML markup. And to show you nothing, again, nothing up the sleeve, I'm going to do the view page source. And this is what actually is outputted. So just like when you output it to the command line, this is what the browser is seeing and then displaying. So also, again, nothing, because I like, showing the full thing, and then I create a little script. The script took me all of 5 minutes to write, and I think I'm not even sure it's that long. List users.php. Start out by printing out my head, my HTML head. I gave it a title. I created a table for it, calling it, ID, first name, last name, and email. And a try-catch statement, as we talked about last time, I just do a real quick select from that user input table we created and just insert it into. Run the query, and did a fetch all, so it returns all the rows back as an array. So turning all the values back. Just in the catch, I'll return an error if something goes wrong. And then I do a for each, so it goes through every value of the rows that we return, so basically looping through each of the rows returned, and then just outputs them. So it's, I'm using 20 lines of code. I could use the class if I wanted to, but there are lots of different ways to write this data, but it's fairly simple. And what I get back out here is a script list of users. This is what I did for testing it earlier, and then I'm going to refresh. And the blank one I sent through, and then our 2 tests. So you see how they're displayed. Notice we don't have emails for them because we didn't pass the email parameter through. Again, this is simple web forms, not a lot of code here. You can look at, the number of characters in here. We didn't have to write any special handlers. We didn't have to bring in any special modules. All of this is built in natively with the PHP module. It's all there for you. This is the big part of where PHP comes in and why it is such a good language for getting up and running, writing web code, because it doesn't take that much effort, and you don't have to jump through a bunch of hoops to do it. I personally came in, before I ever wrote a bit of PHP, I've been writing Perl and Perl web code for years. And you had to install special modules and all special handlers and special trappings and everything else just to get some basic web code up. It's PHP, why it came out of that is, it started out as Perl scripts, basically because they wanted something simpler. They wanted something easier to write. This is why PHP is nice for web code and why so much of the web now runs on it, is because it is easy to write in. It is simple. It's not something where I'm telling you this, and this is just a little tip of the iceberg that then you have to learn 500 other commands to do. No, this is the functional code here. This is how you build, everything else you want off of this. Everything else off of this basic web stuff, the basic form field and the basic database handling, if you think about it, most everything else comes off of that. You go to major banking website, what are they doing? You have your login page, which is a form. Submits, checks against the database, which is a select statement against the database, probably does some, logging in the back end. Brings up a page based on your particular, information. Will then go, you tell it, you click, it'll generate a whole page that includes, your balances and your accounts based on your user. There's just more select statements. You click on the one, it's just a link, that's generated, which would be a GET request based on your, your account. You click on the first account. That does another select on the account number. Returns the data with some other GET stuff, withdrawal, what have you. This is it. This is most of the core. This won't get you the pretty. This won't get you some of the more dynamic features. That's some other advanced stuff. But this is the core here. There is not that much to it. However, that said, let me throw a few more things at you. So again, using it with Informix, as we saw there, it's pretty straightforward. First name, they come in from the request. We have an insert line. We prepare it, and then we just execute it. Sort of passing the execution 2 variables, first name and last name. They match up with the 2 parameters here, first name and last name, and we'll insert those 2 values. Again, I mentioned this last time. I will mention this again. I will mention this next class. Always, 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 every single bit of data coming in from a website or from a remote user, always put it in using a prepared statement. Do not pass data directly from user input into the database, just in quotes, it is unsafe. Please do not do that. And honestly, this is generally faster and makes your life much, much easier. Next thing to talk about is sessions. Some of you may have worked with cookies in the past. Cookies are a pain to work with, to be honest, and they're insecure. For those of you that are not familiar with the terminology, a cookie is a little file that is stored inside your browser. When you say clear cache, clear cookies, etc., what it is it's a little bit of data that is stored by the server about you in your browser. So the next time you come back to that website, that server can read that browser and get information about you. This is the old way that browsers or that websites would keep persistent data between your web sessions. So that one page to the next, it would very easily be able to see who you are, know information about you, know what controls can work with, all that other good information that they want on you. They can do that. Now cookies are mainly used by people trying to have obnoxious pop-up ads in other parts of your browser, and have ads that track you on Facebook and everywhere else you go, so you get all the targeted ads, because they're a little less secure and they're a little more open. And the reality is you can go delete your cookies anytime you want. You can go edit your cookies anytime you want. I remember one of the major companies back in the late 90s had in one of the cookies is admin, YN. That was an old thing where they didn't, they weren't they trusted the users not to mess with their cookies or just otherwise didn't think about it. Nowadays, we know better that they are not going to, we can't trust users. We can't trust anything that comes from users. So this is where the idea of sessions came in. Trying to do these with some other languages is a real pain. PHP, it's built in and works quite well. What it does is there is the session variable, just like there is with global variable, just like with PostGet, it is global. You don't have to source it in anywhere. What it does is it does store a cookie in the user's browser, but the only thing it stores is a unique identifier. It's a long string, and what it will do is just gives consider a passcode to the server, which that's the only thing it's relevant to, and will only last for a limited time, which you can define. But what it does is when a session starts, it'll go check to see if that cookie is there. If it's not, it'll create it. And what it does is that cookie, the long string of ID, and I'll show you what it looks like in a minute, ties to a file on the server. And you can define where it is. By default, it is in your temp directory. That will basically be the cookie stored there, but it can store any kind of data you want it to. Again, they'll stick around. Be aware if you have it in your temp directory, if you have a publicly shared server, it means this data is not secure. Depends what you're storing. If the only thing you have in there is some basic session information, that's probably fine. I've seen some places where they store a password or a password hash in there. That's not so fun. So keep in mind what you have there. You may want to have your session variables stored or session files stored in a directory that only the web server has access to, so you don't have global read access or write access for that matter. There are two variables you have to include, or two functions you have to make it work. The first one is session_name. This is a unique name for this application. If you only have one application on your web server, it's not a problem. It'll create one dynamically for you. But if you're running multiple applications, most people do, you have your banking application and you have your timesheet application and you have whatever else, you'll want each one to be separate unless you want somebody to have single sign-on to all of them. But most times you'll want them separate. So session name, we'll give it a unique name. So everything then session-wise will be only for that unique session. You don't have to worry about it being bled over or any kind of conflicts with any other applications on that server. All of these are unique to the server. So if you move between different servers, there's no way to access the session information from one. There are some third-party solutions if you have things like a big cluster of web servers to handle this, but that's a little outside of the scope of this talk. The second function, this is the most important one, is session_start. Without that being executed, their session is not running. You can tell there are some flags you can do it automatically on. but most of the time what I do is I just embed a session start at the beginning of my header file, so it is always called on every page visited. So it's the first thing that's called. So at that point, the session is now active, and you can actually then use the session variable. So in this case, a quick example, session name, test session. So we're initializing it with that when we call the session start. So it'll now create a cookie in the browser if it's not there already, or if it is, it'll read it. And then all we have to do to use it is use the session member associative array, or it's actually an array period. You can use any type of data you want storing in it, and just tell it variables to store. In this case, it's off of the input, and then it just outputs it, outputs the session. So again, nothing up my sleeve. Session example here. I've created a session. Actually, I'm going to pull up the code first. Very simple session start. Calling it simple sample session start. We're going to check for I'm using isSet to see if it is set at all. So if it exists, the your name variable. If it is set, we're going to set the session variable of name to that value, and we just use the your name is set to it as well. Otherwise, we're going to set your name is equal, blank, and then output a form here. So there's a simple form, simple HTML, form action, session example, input type. So it's the action is the same script. So it's going to post the data back here, or send the data via get back here. Your name, and then just the output. I'm setting the value being to your name, so it will display, and then a submit button. 21 lines of code, nothing too extreme here. So I'm going to put in my name of Tom. You see it passes your name, Tom, and now it's created a session cookie of Tom. And what I can do here, I've got session example B. Second script, or sorry, session example 2. And all it is again, I call the same session name, because again, if it's a different session name, it won't pick it up. Start it, and then all I'm going to do is print out simple HTML page with your name and then the session variable of name. That's all there is to it. Now I have variables that I can track from one page to the next. Doesn't matter if they leave to the website and come back. Doesn't matter if they jump around or cut and paste and don't directly follow the path I left out for them. I will know who they are. I can track them as long as that cookie is valid. If they clear cookies in the browser or change browser or change computers, they're going to have to log in again. But this is the other thing PHP does really, really well. I will mention there are other ways to implement the sessions. I've seen some people that do a similar cookie and then store the data in the database. There are lots of other ways to handle this, which is perfectly fine. It just means rolling your own option. This is something that comes built in with PHP. For the most part, is reasonably secure. Let me show you what a cookie looks like here. I think I can do it from my browser here. So this is actually, there's a little Firefox add-on called Web Developer. I really recommend it. It's a lot of useful information in there. But this is what the cookie actually looks like. So the name is sample session. The value, this is the unique identifier. Gives me a host. This is the server host. The path, this is just information about the cookie path. Expires at the end of session. Secure, HTTP only. These are all different. Again, where I say you can, really mess with the cookies. Notice the big edit button right here. I can go into any cookie in my web browser and change the values. If I change this value here, though, to anything else, it's not going to do any good because the web server is just going to see it, view it's a stale cookie, because it's not going to match anything, and move on with life and create a new one. So to show you what it actually looks like, I think I have these in temp. Yeah, I apologize for where I actually put the temp files here, but normally you'll actually have a file in your temp directory for your for the cookie or for the session variable that actually have your session information in it. So the other piece I'm just going to mention here, what is the temp directory? Okay. Apologize, have not hit this in a little while. Is in your PHP INI, you can actually change the default session is the cookie name, how the different the cookies are actually stored. That's where the path is. I'll go to that in a moment. But this is where you can actually change your PHP INI file, how the sessions are actually stored, information on the auto start, the lifetime, all these things that you can change if you need them to handle it in a different way. The only one I generally change off the bat is the cookie path, because I'll put that actually into a path that only the web server can use. And you notice the big long string here, the SES underscore and then the name. This matches the name of my cookie. And if I actually view that file, you actually see it's in JSON, or it's in a key pair value, but all you see is the name, the information is the byte length, and then the value of the name. I can actually, again, why you want this secure, you don't want other users on your web server to be able to do this and be able to mess with other people's cookies for obvious reasons, or other sessions for obvious reasons. But I mentioned, I just mentioned this for security purposes. Anything you build on the web, you want an eye for security. You don't want to have to build an application and then go back and put your security features in. You want to build it from the ground up with security in mind. Go back and obviously audit afterwards, but you want to think through these things and put it in as secure as possible from the get-go. The web's a dangerous place at times. You don't want people being able to, get in through your system. You never want to be the cause for that. So where do you go from here? Let me explain why I have this slide in here. We're going to talk on the next webcast about how do we actually kind of tie all this together. How do we make it look a little nicer? How do we tie in some other functionality into it? How do we actually take it and create more of an application out of these different parts? I'm also going to cover some fun little useful pieces that may be relevant to some people on here, such as integration with WordPress, for example. That's one of the big players, and some of the other things to look out for. So it's going to be a little bit of a jump around, but I want to kind of bring some of these core functionality, these features together from the last few classes. But why I brought this slide in here is some other things you may want to research. If you're seeing this stuff going, hey, I can do that, or hey, I've got an idea and I want it to do X, Y, and Z, here are some things you may want to do some research on. And I'm going to talk just a little bit about them quickly. The first one is JavaScript. A lot of people have written JavaScript at some point in their careers. If not, it is somewhat C-based. But what it is cool about is it's a very simple script, or fairly simple scripting language. Runs entirely in the browser. So this is where you can have dynamic functionality, whether it's a pop-up in the screen, or dynamically as you type in a field, it does something with it, or dynamically fetching more data for the system, whatever it may be. That's JavaScript. jQuery is a free set of effectively full language add-on to JavaScript that you get from jQuery.org. It simplifies a lot of common JavaScript functionality, does some of it much easier for handling trapping form elements and doing modern web, as I like to say, Web 2.0 things. Has some great functionalities for Ajax, and I'll talk about that in a moment. So it is something that's worth looking into. It's being far more widely adopted. I know some people hate it. Some people really like it. I go back and forth depending on the day. but it is very cool technology. So if you want more dynamic web pages, you want web pages that actually do direct feedback to people without having to refresh the page, that's where you want to go. And you can tie in those back into your PHP code and actually generate your JavaScript in PHP. So your server requests the PHP code, sends it back up, and as it's producing the browser is creating displaying the web page based on the HTML, that JavaScript you've created will pop up as well and function normally as JavaScript. So you can tie your data in that way. Ajax is like the core of Web 2.0. It's asynchronous. I don't remember the full thing is. Basically what it is, I can never remember the full acronym for it, but what it does is it's an asynchronous model where JavaScript calls through your web page after it's already been processed are requesting more content. Whether it is pulling the latest status feeds, on your favorite social media site to pop them up at the top without having to refresh the page, or submitting a form without refreshing the page, just taking the form elements, sending them out and sending back a success message. All sorts of things you can do with that, dynamically change around the page. All of that is done through Ajax. If you're interested in that, do a little Googling. Actually, if you use the jQuery libraries for it, you can have a simple PHP-based, script set up where the Ajax requests data from the PHP or posts it to that PHP script, returns the data. It's 20, 30 minutes worth of work. If there's real interest, please let us know. We can actually look at doing a future webcast on that. But it is something certainly worth looking into as more web pages are trying to be dynamic. It's a very nice feature. The next thing is, if for security reasons you cannot store your session information on the server in the file system, there's a number of things out there. There's a couple of libraries and a lot of people that have written guides to actually do session storage in the database. You can certainly do this inside of Informix. You could include word-level encryption based on the application access user account in there, and actually store encrypted all that session information, retrieve it through a cookie or through a number of other means. It's something to consider depending on what kind of application you're writing. Most simple applications, it's just overkill, but if you're working with something like banking, or you're working with something where this is really going to have, like Sarbanes-Oxley, or somewhere you're really going to have a lot of auditing, you probably want to look into it. The last one that I'll touch on a little bit next time, but not too much, is cascading style sheets, where this is the meat and potatoes of styling nowadays on websites. This is giving different elements the attributes of how they should look, whether it's the font size of your forms, or what font they should choose, or how wide should this thing be, or what direction should that be. Should I have the picture up here and have the text flow around it? However you want the page to look and feel, that's where CSS comes in. And the nice thing is, because these are outside files, you can have templating for the look and feel of your site with just a replacement of your CSS script, depending on how complex you want to make it. It's some very powerful stuff. It can get very complex, and it is not consistent across all browsers. For those of you on the call that may be web developers already, at least I can tell you, for me, this is my biggest headache, creating websites. I spend more time messing with the CSS than I generally do writing traditional code, just trying to get it lining up right and looking correct across all browsers, but it is still the standard these days. So it is something, if this is a real interest for you, I would do some reading up on CSS. And obviously, if you've not worked with HTML before, do some read up on that before. It has not changed much in the last 15 years. So if you have any old books around, they're probably still completely relevant. We've just gotten rid of, the scroll and marquee, functions, thankfully. If you don't know what those are, go look them up. They're frightening. Anyway, just some more. These are the same links you've seen before. Just information about PHP, the Zen framework, the IEG's open source initiative. Lots of information out there on this stuff. Google is very much your friend. The PHP website, honestly, is really your best friend for figuring out which functions, what the syntax is for the function. you put in there saying like the session, you'll get all kinds of the different argument or the different elements of session. It really is the best documentation I've seen. One other thing here that I want to announce, and I apologize I missed the slide for this, June 24th, we are going to be doing the webcast for the next Fastest DBA contest. This year it's going to be starting in July, running through September, and it is going to be on actual SQL tuning. You know, this is looking at it either from the application developer standpoint or from the DBA that has to fix what the application developers have suddenly slowed down your system on. But it's going to be entirely SQL, no on-config tuning this time. So the webcast is going to be June 24th. We will be posting soon information on that webcast on the website, so stay tuned for that. Thank you very much. If you have questions, go ahead and send me a message with them. I'm trying to from my little chat box. Send me a chat message here, and I will happily answer it. Also, if you don't want to ask the question right now, my email address is on the sheet. I've plastered it all over the place. Feel free to email me any questions you may have. I'm more than happy to answer them. If there's anything you would like to see covered for the next one, because I am still building that one a bit, please let me know and I'll try to incorporate it. Give it another minute to see if anybody has any questions. All right. Well, I am not seeing any questions. Doing one more check just to make sure WebEx isn't hiding them from me. Don't think so. All right. So I'm not seeing any questions. So please feel free to email me with any questions or requests you have. The next one is going to be a little bit more on some advanced topics, some fun side things. You know, here's how you do this. I'll be putting up all the samples I showed today up on in another sample pack. They will be just an extension of the last one. So let me know if you have any problems executing them, have any questions on why I did this, that, or the other thing. And thank you very much for listening and being here for this. Lester, do you have any announcements?
Thank you, Tom. This was another real good webcast. I just want to announce to everybody, if you haven't already heard, Tom Beebe was selected by IBM as an IBM champion for this year. And so congratulations, Tom, on that. Phenomenal job you've done with that. And again, thank you everybody for attending, and we'll see you next month at our webcast.
Thank you very much.